Hello everyone, in this video we're going to learn about magnification and spherical surface. So let's go to the first one, which is magnification. For magnification, we have two equations, negative V over U and also HI over HO. Now let's look at the sign for each of it. V, as we know, is the image distance. So if the image distance is positive, it means that the image is real. If it's negative, it is virtual. U is the object distance. If it is positive, it is a real object. If it is negative, then it's a virtual object. HI is the height of the image. If it is positive, it is upright image, which is normally referring to the object. If it is negative, then it means that it is inverted, going downwards like that. If it's upwards, and then it's one downwards. HO is the height of the object. Normally, if it is positive, then it is an upright object. If it is negative, it is inverted object. Now let's take a look at how characteristics of an image can just be defined using magnification number. So magnification consists of two parts, which is the sign and also the numerals. If the sign is positive, that means that the image is virtual and upright. If the sign is negative, then it is real and inverted, which we're going to look at it later. Okay, you will see how I help you to define the characteristics of the image just based on magnification number. Next part is the numerals. If the number is less than 1, the image is diminished. If the image is more than 1, it is magnified. And if it is same as 1, it is the same size. Now let's take a look at this example. Here we have m equals to positive and 3. So positive means virtual and upright, just like this one. Here we have positive, it is virtual and upright. And the number 3 is bigger than 1, hence it is magnified, like this one. Now let's try more examples. Here we have negative and 1. Negative is real inverted, and then 1 is same size as the object. Next we have positive and 2. Positive is virtual upright, and 2 is more than 1, hence it is magnified. Next, we have negative and 0.3. It means that this image is real inverted, and since 0.3 is smaller than 1, we're going to say that this one is diminished. Next, we have negative, but this time we have 5. Just now we have 0.3, which is less than 1. So here we have real inverted, which is the same as the number 3, but here we have the number is 5. So this one is more than 1. That means that this one is magnified. Next, we have positive and 0.7. It means that this image is virtual upright and diminished. Next, we have negative and 2.5. It means that real, inverted, magnified, because 2.5 is more than 1. Do not confuse with negative 2.5. If you say that negative 2.5 is lesser than 1, then you're going to get it wrong. Put it in separate parts, which is the number, the sign, and also the number. Okay, next we go to positive and 0.4. Positive is virtual upright, and because 0.4 is less than 1, it is diminished. Next we have negative and 0.8. It is real inverted and diminished. Yes. And the last one, we have positive and 0.1. It means that this one is virtual, upright, and diminished. Next we go to the refraction on spherical surface. The equation is n1 per u plus n2 per v equals to n2 minus n1 over r. Now this one, in order for us to use this equation, we have to know two parts. Number one, we have to know which medium is N1 and which medium is N2. N1 is the medium where the light comes from, while N2 is the refractive index where the medium where the light goes to. Like for example, we have this sphere. This is a glass sphere. So here we have light rays hitting the first surface. Now, since the light rays coming from the air into the glass, the N1 is the air and N2 is the glass. Next, the light rays continues hitting on the second surface. Now, on the second surface, the light rays is hitting the surface where it is coming from the glass, this glass, and try to get out from this glass into the air. So this time on the second surface, the N1 is the glass and N2 is the air. Now let's go to the R. Before we can use the equation, we need to know either the R is positive or negative. We can use the concept suka boncit. Like for example, this situation. Let's say light rays hitting on this curvy surface. Here we can see that this is boncit. Hence, the R, the radius for this circle, is positive because we like boncit surface. Next, we have this one. This is kurus because it's hitting on the dent surface. Hence, we put the R as negative. Let's try this tutorial. An object is placed inside a hemisphere glass paperweight and 12 centimeters from the surface of the glass. Okay, so we have our U. The radius of the glass is 20 centimeters. Okay, we have the R, but we don't know whether the R is positive or negative. Okay, then the refractive index of the glass is 1.5, and the refractive index of air, this is actually of air, is 1.0. Calculate the image distance and state whether the image is real or virtual. Right. The first thing that we can do and help us so much is by sketching the diagram. So this is the object. The object is inside the hemisphere. And then this object, the light rays coming from the object going out to the air. So this is the glass and this is the air. So because of this, we can see that the light rays hitting on the kurus surface, hence the radius is negative. That's how we know. Next, we're going to use the spherical surface equation. N1 is the glass because the light object coming from this one, object produces light rays. So it is from the glass to the air. Object distance is 12. The air is the N2. We are looking for the V, N2 minus N1 over negative 20. Why is it negative? Because this one is kurus. Hence, the answer is negative 10 centimeters. And because it is negative, it means that this image is virtual, where it formed in the glass, which is the same side as the object. Let's take a look at the second example. A fly is trapped inside a solid glass sphere of refractive index 1.5. The diameter of the ball is 16 centimeters. We have to find the radius, right? An observer outside the sphere sees the image of the fly located 6.4 centimeters inside the glass from the surface. So the image now looks as if it is still inside the glass. Calculate the real position of the fly from the surface. Alright, so first thing we have to do is to sketch. So we sketch like this. We have our V here. We are looking for the U, right? So based on this, we are given the diameter of the ball, which is 16 centimeters. Let's get the R. Now, the light ray is always coming from the object. Now, remember this, always coming from the object. So, since the object, which is the fly, is inside the glass, the N1 is the glass, the N2 is the air, because the light ray is coming from the object, hitting our eyes, which is the observer. So here we can see that the curve is kurus, hence we have to add in the negative sign. Okay, another thing is the image formed in N1 is V, which is negative 6.4 centimeters. Why do we know that? Because the image, even though it didn't say anything about the negative sign, because it is inside the glass, which is in the same side as the object, it shows that this image is virtual. Okay, so remember that if the image is formed on the same side as the object, have to add in the negative sign because it shows that this image is virtual. Now that we have our R, we have our V, let's substitute. The N1 is 1.5 because the light ray is coming from the glass to our eyes. This is N2, which is refractive index of the air. You were looking for, don't forget to add in the negative sign of the V, which is a virtual image, and don't forget to add in the negative sign of the R because this is kurus surface. And the answer is 6.86 centimeters, where this object is a real object. This object is in the glass, which is on the same side as the image form, which is the virtual image. Alright, let's go to question number 3. A bulb is placed next to a glass of a sphere of radius 10 centimeters, and then we have to find the object distance such that the image is formed at infinity. So it means that the V is at infinity. So we have here the bulb. Okay, and this is a glass sphere. Obviously, the light rays coming from the bulb hitting the surface, which is, this one is bone chip, right? And then hitting and enters the glass sphere. Hence, we can see that the N1 is the air, and then the N2 ialah kita punya glass. And also sebabkan dia punya surface tu bone chip, so R kita akan jadi positif. So, we're gonna use it in our spherical surface equation. Dan kali ni kita akan pastikan kita punya V ialah kosong, sebabnya V dah sedia dekat infinity, kan? So bila kita substitute, now perhatikan yang N1 kita datang daripada udara dan N2 kita datang daripada ialah pergi dekat glass, gitu. So R kita pun positif sebab tadi kita dah tengok dia boncet, right? And the final answer is U equals to 20 centimeters. Now this object ialah objek yang real, which is at the outside of the glass sphere just now.